What up, everybody? This is Unit 9 review. So this is all about sequence and series again. If you haven't watched any of the videos, the key to success in this unit is for you to at least print off or have very readily available to you the formula sheet. Again, unless you memorize the stuff or you know something that I don't know, the formula sheet is going to be your savior in most of these questions. All right, so take a look through it. I know we haven't talked about the quote-unquote recursive formulas a whole lot. They are on the test. So again, to create a recursive formula, all you pretty much need to know is the common difference or the common ratio to make those things happen. But again, you know how to do that, and I'm really not that concerned about that part of the question. And when they do come up, hopefully it's on this. I'll talk about it a little bit more. Okay, so with that being said, let's go ahead and get into it. All right, so is the following arithmetic? Again, for something to be arithmetic, that means you add to the next, to the next, to the next, to the next. So that means it needs a common difference, a2 minus a1. So negative 16 minus negative 8 is negative 8. So if this thing is subtracting 8 every single time, getting this next element, it's all good. However, if any of those are not a minus 8, then it's not okay. So let's go ahead and get started with this. So negative 8 minus 8. Negative 16, good to go. Minus 8. Negative 24, good to go. Minus 8. Negative 32. So every number that they gave me is a minus 8 of the previous. This is good to go. This, yes, this is quote-unquote arithmetic. Given the explicit formula, blah, 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 find the first 5 and the 52nd. Okay, so they did all the hard work for us. All we have to do is just figure out what this is and how to get to the next, to the next, to the next. Okay, this is arithmetic. So that means there's going to be a common difference. So anything. So the first number, A1, is when I make this N1. So that's 20 times 1 minus 39. All right? So 20 minus 1, 20 times 1, good gravy. Come on, Ashton, you're better than this. Try this all over again. Hold on, that. All right, let's try that again. A1 is going to be 20 times 1 minus 39. So go to your calculator, decimals or otherwise. Type it in, negative 19, huzzah. So the first number is negative 19. Second number. Okay, it's 20 times 2 minus 39. 1. Okay, because I see that this is indeed arithmetic, that means I'm adding to the next, to the next, to the next. Okay, because I'm adding to the next, to the next, to the next, I see that common difference is 1 minus negative 19, aka 20. So what I'm doing is I'm adding 20 every single time. So from here, it's pretty easy. This is 21, 41, 61. If I add 20, 20, 20, 20. Right? And now the 52nd term, I go back to the original explicit formula, and I make the n 52. $1,001. Leave the chart. All right. Find the common difference. What's the explicit formula? What's the 52nd term? All right, so the common difference, A2 minus A1 is negative 7 minus 23, that's negative 30. A1 is 23. AN, okay, again, this is DN plus A1 minus D. All right, so I usually don't write this, but you can kind of see what I'm doing here. So this is negative 30, N, A1 minus D. So that's 23 minus negative 30, so that's going to be positive 53. And then what's the 52nd term? So A of the 52nd term would be negative 30, 52nd term, plus 53. All right, here we go. So the common difference was negative 30. The explicit formula is negative 30n plus 53. The 52nd term is negative 1,507. All right, find the explicit formula for an arithmetic. Okay, so this is arithmetic with a common difference of 4 and whose first term is 3. All right, so the common difference is 4, first term is 3, so AN is equal to the difference, and A1 minus D, so that's 3 minus 4, so that's negative 1 all day. Geometric. Okay, so geometric, make sure you take a look, and we have a whole category of geometric. So geometric is multiplying. So is the following sequence geometric? So we would have to have a common ratio, which is A2 minus A1, so that's 20 divided by negative 4, so that's negative 5. Are we multiplying by negative 5 every single time? Let's check it out. So we go negative 4 times negative 5, 20 times negative 5, negative 100 times negative 5, positive 500. Yeah. Okay, all of those numbers do check out. That is what it is. Find the common ratio of the next 3 terms, and yeah, okay, easy peasy. Okay, so the common ratio is 8 divided by 4, which is 2. So what I'm going to do is I'm just going to multiply by 2. And what I'm going to do is I'm going to get, so I see the common ratio is 2, I'm going to get the next 3 terms. So 4 times 2 times 2 times 2 times 2 times 2, etc., etc., etc. So that went from 16 to 32 to 64 to 128, etc., etc. So the next 3 terms would be 32, 64, 128, etc., etc., etc. All right, given the sequence, find the common ratio, explicit formula for, okay. So the ratio of this dude is 20 divided by negative 4, which is negative 5. A1 happens to be negative 4. All right, the explicit formula is A1 R to the n minus 1. So in this situation, that is going to be negative 4, negative 5, n minus 1. We want to know the 8th term as well. So the 8th term is negative 4, negative 5, 8 minus 1, or aka to the 7th power. There it is. Then we just have to make sure we record the proper answers in the proper places. Okay, so the ratio was -5. The explicit was -4, -5 to the n minus 1. And the eighth term came out to be 312500. Easy peasy. Red here. Identify the first 5 terms of the sequence A1, AN, blah, 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 blah. Okay, so the first term is obviously 3. Oh, okay. Okay, so this is using quote-unquote the recursive formula. So they give us a statement that says AN is equal to A, excuse me, as you were, gives us 5A n minus 1. Okay, what the deuce is this n minus 1? Okay, for instance. Okay, so if I'm looking, for instance, the second term, aka n is 2. So if I'm looking for the second number, which I am right here, what this is saying is this. I'm going to take 5 times a n minus 1, or aka 2 minus 1, which is 1. So what this a n minus 1 is aka the previous number. It's the previous number. That's what a n minus 1 is. So if I'm taking a look at the second number, okay, if I'm looking for the second number, I'm going to take 5 times the first number. That's in essence what the recursive formula is. If I'm looking for the second number, I'm going to take 5 times the first number. So the second number would be 5 times 3. Okay, thus the third number is going to be equal to 5 times the second number, etc., etc., etc. So times 5. Okay. And now, so you just times 5 from the previous number. So the previous number times 5. The previous number times 5. Previous number times 5. So where are we at? 3 times 5 times 5. Oops. Sorry. The math was off. Sorry. 75. Okay, so the fourth is the 5 times the third. Okay, so that is your introduction to the recursive formula. This is this right here. Okay, this is a recursive formula of a geometric set. So if you see this a n minus 1, okay, you'll see it again right there in the other recursive formula. What the a n minus 1 is just the previous number. So if you're looking for the second number, you have to build off of the first number. If you're looking for the fifth number, you have to build off the fourth. Okay, given the following, choose both the explicit and the recursive. All right, so, okay, this is an arithmetic. Okay, so they straight up tell us that it's arithmetic. So that implies that the difference in this situation is going to be 31 minus 35. A1 happens to be 35. The explicit is going to be the difference times n. 35 minus -4 is positive 39. And then the recursive, so this is the explicit, and the recursive, let's just take a look at it. an is equal to, the recursive is, in arithmetic, is a n minus 1, so leave that as a n minus 1, plus b, so plus -4, or aka -4. So that should be my explicit and recursive formula, something very, very similar to that. Okay, so I'm assuming that there's a typo down here. I think one of those is supposed to be the explicit formula. It's either the answer key is wrong. So I'm supposing that that was supposed to be the correct answer. I think that 30 should have been a 39. So, but they don't show the explicit formula. The recursive formula is the -4, and so that is indeed the recursive formula right there. Okay, so again, so nice, play it twice. Choose both the explicit and the recursive. All right, so the difference is -10. A1 is -24. Explicit is difference. And -24 minus -10 is -14. So that's the explicit. The recursive is an -1 plus b, or aka -10. So let's just pick those. So there's our recursive and the explicit. Okay, now we're switching to the same questions, but of a geometric set. Okay, so same idea. So jump down into the formula sheet, take a look at the explicit and the recursive formulas of the geometric set. So here we go. The common ratio is 16 divided by 4. A1 happens to be 4. Okay, so explicit formula. An is equal to A1R to the n minus 1. And the recursive formula is An is equal to An minus 1 times R. So pick something that looks something like that. So there's our explicit. And then 4, just a regular 4, there's our recursive. Okay, find the explicit of this geometric sequence. So here we go. The ratio is 4. A1 is -1. Explicit is A1. Ratio n minus 1. Recursive is the previous number times R. Previous number times R, that's the recursive, and -1 for there's our explicit. And just follow the formula, follow the formula, follow the formula. Free money, free money. Common difference and the 9th term. All right, so this is obviously arithmetic. So this is going to be 11/6 minus 5/2. Well, calculator, don't fail me now. -2/3. A1 happens to be 5/2. Explicit formula is difference, n, then 5/2 minus 2/3, so A1 minus D, so that is 5/2 minus -2/3. 17/6. And then we want to know the 9th term. There it is. All right, so the common difference was -2/3. And the final term was -17/6. All right. Okay, now we're getting into summations. Okay, now we're getting into summations. So the first thing that we need to do is know, is this a geometric or a arithmetic? So if this is arithmetic, then this would be a 0.9 minus 0.5. If this is geometric, this would be 0.9 divided by 0.5 is 1.8, I think. Yeah. Okay, so it's either we're multiplying by 1.8 or adding by 0.4. Hopefully everybody sees that you're adding by 0.4. If not, you can test it out. All right, so I see that this has a difference, not a ratio. Thus, this is letting me know that this is arithmetic. So that means I'm looking at a summation of an arithmetic sequence. So, so I see here that A1 here is 0.5. I think that's everything that I need to know. Okay, so I'm looking for the sum of 10 terms. 10 terms. So let's go ahead with this formula. Follow the formula. 1/2 n first plus, ooh, snap, I know what I need to do. I need to find that last number first. I need to find the last number of the sequence. So I need to find the 10th term. So an is equal to the difference, n, and then a1 minus that, so this is plus 0.1. So I do need to know the 10th term. So a little bit more work to go on here. So I'm going to make that n 10. So 0.4, 10, plus 0.1, 4.1. Yeah, okay. So now I have enough information. So 2, 10 terms, first term, last term, the summation of the first 10 terms, $23 flat. All right. Getting closer, getting closer, getting closer. Arithmetic, okay, they straight up tell us sum of the first 4 terms. All right, so what you could do technically in this one, because the set is so small, is you can see that the difference is 10. So this is going to be 35, 45, 55, and you can literally just add that stuff up. I think it was on the last video. I think that adds to 160 or 180. $160, yeah. All right, so because the set is so gosh darn small, you can do it this way. All right, or again, you can jump through all the hoops. So the difference is 10. A1 is 25. That means AN is equal to 10. N 25 minus 10 is 15. And so that means that the fourth number is 40 plus 15, 55. So you could do it as the sum of 1/2 n a1 plus an, which is going to be 1/2 4 terms, first term plus last term. And believe me, that's going to come out to be 160. So either way, because it's so small, you can just literally grind it if you want. Common ratio and the 10th term. Okay, so this is a geometric, obviously. -24 divided by 6, -4, a1, 6, an is a1, r, n minus 1. They want to know the 10th term, aka to the 9th power. So 6 -4 to the 9th power, and something huge, 1572864. So the common ratio was -4, and again, -1572864. Boom. What is the sum of the first 8 terms of this geometric? So the ratio is 12 divided by 3. A1 is 3. I think that's all you need. So the sum of a geometric is A1, 1 minus r to the n, divided by 1 minus r. Pilot's favorite letter. So this is 3, 1 minus 4 to the n, 8 terms, divided by 1 minus 4. Again, I encourage you to get a top answer, bottom answer, and then divide it 2. So the top is 3, 1 minus 4 to the 8. So 19605. 6605 of -3, 655. Just can't write the numbers. 65535. You can chop. Boom, roasted. This is the last sum of the first geometric. Oh, okay, another summation. So as we're r 3, a1, -2, sum is a1, 1 minus r to the n, 1 minus r. Divided by -2, and the winner is 14 million something, or yeah, 14 million something. 348 48906. Boom. That's it, kids.